this, just like yesterday, I'm going to have you start with a warm-up that is going to lead very well into today's lesson. I'm going to give you some time to see the answers and ask each other questions about last night's homework, and then we're going to move into today's lesson. So please pause for 2 minutes to allow students to answer this warm-up question. All right, so I see that I'm taking the derivative of the product of two expressions here. And so what that means is that I need to use the product rule. And so I'm going to take the first times the derivative of the second, which is cosine x, plus the second times the derivative of the first, which gives me x cosine x plus sine x. Second problem, same scenario. First times the derivative of the second, which is just e to the x, plus the second times the derivative of the first, which is 2x, which if I simplify, I get x squared e to the x plus 2x e to the x. Here are the answers to your partial fractions homework. Please pause here and take as much time as you need to answer questions. Okay, I have a feeling, sorry, I'll have you pause in a second. I have a feeling you had a hard time in number 8 and perhaps also in number 11. The thing is that your argument was 2x plus 1. So you needed to do u substitution, and then du was equal to 2x, which means you needed an extra 1/2 out front, which is why these came out to -1/4 and +1/4. Same scenario in number 11. So that's me anticipating something that students usually struggle with. Okay, pause for real now and make sure everybody understands how to do these. Okie doke. So today, you are going to learn another integration technique called integration by parts. This is one of my favorite things in the BC curriculum. I love integration by parts. I think it's so fun. Now, I say that a lot this year, so get used to that. But integration by parts is really, really fun. So hopefully you think of u substitution as backwards chain rule. It's essentially working backwards from a chain rule problem. We have an analog for the product rule, which is called integration by parts. So this is why I had you review the product rule in your warm-up, because what we're going to do today is go backwards from product rule problems. The product rule tells me that the derivative of two functions of x, u of x and v of x, is equal to u times dv dx plus v times du dx. Yes, this is just first d second plus second d first, or whatever your AB teacher said. Now, if we take that and we integrate both sides with respect to x, okay, I just threw integral symbols on each of those terms. Now, in this first one, I see that I have the derivative of an integral. Those are inverse operations, so I'm just left with uv. And I can kind of rewrite this as the integral of u dv plus the integral of v du, which if I rearrange, I get this formula. The integral of u times dv is equal to u times v minus the integral of v du. All right, you do not need to be able to go through that entire derivation, but we do need to know this. The integral of u dv is equal to u times v minus the integral of v du. This is integration by parts, which I'll abbreviate as IBP. And I'm going to show you how to use this formula in just a second. We typically use integration by parts when you are integrating the product of two unrelated functions. For example, the integral of x times e to the x dx. Okay, it's a product of two functions. One is linear, one is exponential. I can't use u substitution. Prior to what you're going to learn today, you would not have been able to integrate this, and that is what I'm going to show you how to do now. First, I have to take this problem and I have to assign what is u and what is dv, because I have the integral of u dv is equal to u times v minus the integral of v du. I want u to be something that if I differentiate it meaning take the derivative of it, it gets nicer, okay? And I want dv to be something that I can integrate. So in this case, I'm going to set u to be x, because when I take the derivative of x, it gets nicer. It becomes 1. And I'm going to set dv to be e to the x, because I can integrate it, and I still get e to the x. So I'm just going to follow this formula. The integral of u dv is x e to the x, that works, is equal to u times v, which is x e to the x, minus the integral of v du. E to the x times 1 is just e to the x, and this is with respect to x. I'm not done. I still have something that needs to be integrated, but this is x e to the x minus, I integrate this and I still get e to the x plus c. And guys, that's it. That's integration by parts. Does it get more difficult? Of course it does. But with simple problems, decide what you're going to call u and what you're going to call dv. U should get nicer as you take the derivative of it. dv should be something that you can integrate pretty easily. And that's it. Follow the formula. Let's try another one. This one has limits of integration. I have the integral of x sine of x dx. This is integration by parts because I cannot do this with u sub. I'm going to define u again as x and dv as sine of x dx, which means du is equal to 1, and v, I integrate sine of x, and I get negative cosine x. Following the formula, uv minus the integral of v du. U times v is going to be negative x cosine x minus the integral of v du, negative cosine x times 1 dx. I'm going to take this minus minus and make it plus plus. And so I have negative x cosine x plus the integral of cosine x is sine of x. I would do plus c, however, I remember this was a definite integral. So I'm going to take this entire guy and evaluate him from 0 to pi. Okay, don't worry about this integral, just wait till you're done and then evaluate the entire thing. So this is negative pi cosine pi plus sine pi minus negative 0 cosine 0 plus sine 0. Okay? The cosine of pi is equal to negative 1. So negative pi times negative 1. The sine of pi is 0. Minus 0 times 1 is 0. The sine of 0 is 0. And so my answer here is pi, positive pi. Isn't that fun? Let's do another. X cubed times natural log of x. Okay, so I need to decide what is my u and what is my dv. Now, my first inclination is probably to put x cubed here because it does get nicer when I take the derivative, the power goes down, and put natural log of x here. However, what is the integral of natural log of x? You were never taught how to integrate natural log of x. I will teach you how to integrate natural log of x. However, right now you can't integrate it. So right now, natural log of x is going to go as your u, and dv is going to go as your x cubed. You have no choice. Du, the derivative of natural log of x is 1 over x. V, integrate this and you get 1/4 x to the 4th. And now I can do this. U times v minus the integral of v du. U times v is 1/4 natural log of x times x to the 4th minus the integral of v du, 1/4 x to the 4th times 1 over x dx. This may look a little icky to you at first, but guys, this simplifies. X to the 4th times 1 over x, that's just x to the 3rd. So this gives me 1/4 natural log of x times x to the 4th minus 1/4 times the integral of x cubed. Which, if I integrate, I get minus 1/16 x to the 4th. I brought this up a power and divided by that power, plus c. And that is actually it for today's lesson, okay? I want you to just do these 3 problems because tomorrow I'm going to teach you a shortcut. Sorry to do that to you again. However, it is important that you understand some of the fundamental aspects of integration by parts. So I do want you to practice each of these 3 doing it the long way. And then tomorrow I'll start teaching you the shortcut.